Okay, thank you very much and welcome back to this afternoon session. This afternoon session we are going to see about the spatial interpolation. We'll have some explanation about the spatial interpolation and then we'll proceed to the demonstration of this spatial interpolation by the use of ArcGIS. Okay. So in this session we are going to see about the idea of interpolation and the deterministic interpolation methods and then basic concepts on statistical methods for interpolation. And we'll see the autocorrelation and first law of geography will be just described in this session. So by interpolation, it is to mean that this is a procedure to predict the values of attributes at an unsampled point given to based on the data which is taken from the sampled points. So the procedure to predict values of attributes at unsampled points. We cannot measure every location. Every location cannot be measured because of these three reasons. One, because of time, because of resource that is many, and because of some constraints or challenges. Impossible challenges will be there, because of physical challenges and legal challenges will be there. So in every geographical location, we cannot just go through and measure everything, So there will be unsampled physical location which could not be measured because of the physical constraint, and some other aspects of data could not be measured because of the legal issues attached with the nature of the data. So because of these three reasons, the impossibility of physical constraints with physical world, the impossibility related with the legal issues, and the resource issue in terms of money and in terms of time, because of these reasons, we cannot measure all locations. So all geographical locations of an event cannot be measured, Rather, we'll take a sample of geographic locations, and from those sampled geographical locations, there will be a measurement. So from the measured geographical location, the result obtained from that sampled geographical location will be used to just interpolate, or in order to just generalize the finding to those unsampled geographical locations. So interpolation is simply to mean that in statistical term, generalization or giving inference for the unsampled geographical locations based on the finding obtained from the sampled geographical area. So that is the idea of interpolation. Just simply giving conclusion or generalization for the unsampled geographical locations depending on the result obtained from the sampled geographical location. So that is interpolation. Because of why do we give interpolation or conclusion or generalization to the unsampled geographical location is the unsampled geographical locations are not included in the measurement because of time, because of money, and because of the physical and the legal constraints that hinder us not to measure the event attached to that geographical location. So rather, we rely on giving inference or conclusion or just prediction of the outcome variable specific to the unsampled geographical locations based on the result obtained from the sampled geographical locations, So the most common geostatistical inference, it is said to be, interpolation is geostatistical inference. A statistical inference and geostatistical inference. Why geostatistical inference? Because we are just giving inference for a geographical data, for a geographical data. That is why it is said to be geostatistical inference. We are giving inference or conclusion or generalization for a geographical data. So that is why it is named as a geostatistical inference, which is the prediction of some attribute or some characteristics or some variable or some outcome at unsampled point or an unsampled geographical location based on some set of sampled units, based on the result which is obtained from sampled geographical locations. So the result which is obtained from the sampled geographical locations will be used to predict the value or the attribute at an unsampled geographical location. That is geostatistical inference or interpolation. So geostatistics is a statistics on a population with known location, with known geographical location. That is why it is said to be geostatistics. So geostatistics is a statistics on a population with a known location. The classical statistics that you have learned previously in biostatistics is said to be simply statistics, because it is a statistics on a population without a known location. Statistics is a study or estimation of a parameter on a population without known location. That is statistics. But in the case of geostatistics, it is estimation of a parameter on a population with a known location. That means that known location is expressed by the coordinates, xy coordinates, or the latitude and the longitude coordinates, So geostatistics is a statistics on a population with a known location. So always we'll have a sample of geographical locations. So from here we collect the data from the sample of this geographical location, the dots representing the collected attribute or the data which is collected from each geographical location, So these dots are the collected events or attributes, the data collected in the selected geographical location. So that is the input or the collected data at a geographic location. And then that collected data will be processed, just that means data management analysis will be made using a software. So we'll manage the collected data, enter into the software, and then we'll develop a map and we'll do any geostatistical analysis, including map development, just different selections, increasing or decreasing the size of the map by just either making a intersect or the union or the merge. All this process will take place, and the further analysis like hotspot cluster regression analysis, all this will be made. That is a process. So the objective of this statistical analysis process is in order to just get an output. That output might be generalization or prediction of unknown parameter on a population with unsampled geographical location. So that will be the generalization or the interpolation. So this is a way that interpolation could be made, or simply geostatistical inference. So interpolation is predicting a value at unknown locations using values which are measured at known locations, So some attributes or measurement will be made at a known location, which is included in the study, in the selected geographical location. So that measured value will be used to predict a value on unknown geographical location over here. So the dots are just indicating over here is the geographical location selected and included in the study for measurement. So the dots are just the place where the measurement is taken. And again, there are dots here, Based on the data collected in these selected geographical locations, we will go beyond that in order to just infer or predict the unknown values in the whole geographical location, in the colored geographic zone. So that is the idea of interpolation simply. So determination of unknown values or attributes on the basis of values nearby. The values collected by the nearby geographical location will be used to predict the values in the unknown geographical location, you know. So spatial interpolation is simply a spatial prediction, or maybe spatial inference. In spatial inference. So let's say we have groundwater pollution as an example. So in order to just collect the data, whether there's groundwater pollution or not, some geographical locations will be selected, you know, as indicated by the dots within this map. So the dots are the geographical locations where water pollution samples has been collected. So based on the result which could be obtained from this geographical location, we will predict the whole water pollution in the geographical area as a whole, you know. So the result obtained from the geographically selected samples will be used to predict the water pollution in the whole geographical area. So that is interpolation. So interpolation, assume we are dealing with a variable which has a meaningful value at every point within a geographic, like temperature, elevation, concentration of some mineral in some geographical location, you know. Then, given the values of that variable at a set of sample points, we can use interpolation method to predict the values of this variable at every point in that geographical location. So for any unknown point, we take some form of weighted average of the values at surrounding points to predict the value at the point where the value is unknown. So using the values obtained from the known geographical location or the sample geographical location, we will predict the unknown values at the unknown or unsampled geographical location. So that means we create a continuous surface from a set of points. Okay, this is the one that already I have shown you. And so that we'll have sample points in a geographical area. Sample points will be taken and observations will be measured over here. And based on this result, prediction will be made, or inferential statistics will be made to predict the whole geographical location in terms of that unknown parameter, you know. So we can predict the values where we did not sample, you know. We can predict the values where the geographical location is not included in the study. That is interpolation. So one requirement should be fulfilled to do interpolation, you know. Interpolation only works where values are spatially dependent, you know. That means the values, the outcome variable that we are trying to measure should be spatially dependent. That values for nearby points tend to be more similar. The presence of malaria in some specific geographical location should be dependent or similar with the presence of malaria in the nearby geographical location. So the prevalence of malaria in geographical location A should be more or less similar or dependent with the prevalence of malaria in geographical location B. There should be spatially dependent variables. Geographically dependent or geographically related variable should be there in order for interpolation to work. So that is a requirement for interpolation, you know. So where values across landscapes are geographically independent, interpolation does not work. If the values or the parameters that we are going to measure in a geographical location are independent, if they are not dependent, then interpolation could not be applied, you know. So interpolation could only be made for a value which is having a spatial dependence. So interpolation should not be used when there is not a meaningful value of a variable at every point in space. So there should be a meaningful value at every point in space. But if there is no a meaningful value at every point in space, then interpolation could not apply, you know. That means when points represent merely the presence of events, like for example it may be crime or whatever, if they only represent the presence of events, or maybe the presence of people, or maybe the presence of some physical phenomenon, like whether there is a volcano or not, whether there is a building or not, interpolation does not make sense. There should be, in addition to the location, there should be a meaningful value of a variable, you know. We need two things should be there always in spatial analysis. One, the location, and two, a meaningful value of a variable. That means the measured value of a variable with its location. These two things should be there. Otherwise, if we are just having only a meaningful value of a variable without location, then interpolation will not work. And again, if we do have only the location but not a meaningful value for a variable, then still interpolation will not work. For interpolation to work, two things should be there. One, the location, and two, the value of a variable. These two things should be there, you know. So interpolation tries to predict value of your variable of interest at each point, at its geographical location. The purpose of interpolation is to predict or to estimate the value of a variable at each geographical location. You see, we are trying to predict a value of a variable on a specific geographical location. So geographic location and value of a variable should be recorded. Okay, so this is the idea of interpolation. You know, what's the difference between interpolation and that of extrapolation? Interpolation is prediction within the range of our data. For example, if you take a data within one region of Ethiopia, then the interpolation will be applicable only in that specific region. Okay, if you take a data on a sample of each region of Ethiopia, then the interpolation will be made to the country level, you know. That is the range of our data. But while we take a data on selected geographical locations of each region of Ethiopia, we cannot make interpolation outside of Ethiopia, you know. You cannot make interpolation for Kenya or for Sudan or for any other type of country. Interpolation is prediction of a value within the range of our data. That means the geographical range where the data is collected. So interpolation will be just applicable to the range of where the data is collected. Interpolation will not go beyond the geographical location where the data is located, you know. That is the essence of interpolation. But in the case of extrapolation, extrapolation is prediction outside of the range of our data. Like for example, if you take a temperature or any other value in the Ethiopia level, and then you try to predict the outcome in to like Kenya or some other country, that is said to be extrapolation. That is prediction of the outcome variable or the value outside of the range of our data. So having a temperature value for a bunch of locations through Ethiopia may predict the temperature values in Sudan. That is extrapolation. So extrapolation is prediction of a value outside of the range of our data. And interpolation is prediction of a value within the range of our data. The range of our data refers to the geographical location range where the data is collected, you know. So if the prediction goes beyond the geographical location where the data is collected, that is extrapolation. If the prediction is within the geographical location where the data is collected, then that is interpolation. Okay. So now, the first law of geography, according to the Waldo Tobler in 1970, is written here, you know. This first law of geography says that everything is related to everything else. But near things are more related than distant things, you know. You see, that is why we say the value of a variable at a specific geographical location is dependent on the value of the variable on the nearby geographical location. That is why near things are more related or more similar than things far apart. So this first law of geography is really very fundamental and central to the analysis of spatial data, you know. Even though everything is related to everything else, but things closer to each other are more related or more dependent than things far apart, you know. That is why the value of a variable is dependent on the geographical location, is derived from this first law of geography, you know. So this is the basic premise behind interpolation. The basic premises behind interpolation. As far as there is geographical dependency of an outcome variable, then we can interpolate or infer the result obtained from geographical location A to that of geographical location B, as far as there is a nearby geographical connection and the outcome variable is related or dependent in between these two nearby geographical locations. That is the idea for interpolation. So near points generally receive higher weight than things far apart, you know. So nearby geographical locations will receive higher weight than geographical locations which are far apart from each other. Why? Because closer things or things near to each other are more similar or more dependent than things far apart. So that is the idea of first law of geography, which is actually the center or the core point of spatial data analysis. So how do we determine this interpolation, the methods of interpolation? We do have two methods of interpolation generally. The first one is deterministic method. This deterministic method of interpolation uses a mathematical function to calculate the values of a variable at a known location based on the degree of similarity. Based on the degree of similarity. Or maybe based on the degree of smoothing in relation with neighboring data points. The degree of similarity of a value of a variable in geographical A with that of the value of that specific outcome variable in geographical location B. That is the similarity of the value of a variable in two geographical locations. Like these are an example of deterministic methods. The one is the inverse distance weight. It does have its own mathematical formula. And the second type of deterministic method is radial basis function. It does have also its own mathematical formula, you know. So these are the deterministic methods that we want to, that means that we can use to interpolate or in order to just do our interpolation, the deterministic methods. The other way of interpolation method is the geostatistical method, you know. So this geostatistical method uses both mathematical and statistical methods to predict values at all locations within a region of interest, to provide probabilistic estimate of quality of interpolation based on spatial autocorrelation, you know. So the interpolation will be made based on the spatial autocorrelation among data points. So the geostatistical method will just estimate the interpolation based on the spatial autocorrelation in between these geographical locations. But in the case of deterministic method, it uses the degree of similarity between the two neighboring data points or maybe the degree of smoothing, So among the geostatistical methods used for interpolation are most commonly we use kriging or co-kriging, and other types of geostatistical methods are also there. There are a number of or a list of geostatistical and deterministic methods that we can use for interpolation. We will see each of the lists in the ArcGIS software, So this kriging and co-kriging have also its own statistical formula, and that the work will be up to the software, We should not bother for the mathematical equations. So these are the ways of or the methods for interpolation: the deterministic method and the geostatistical method. Okay, we can have two types of interpolation: exact interpolation and inexact interpolation. That is the last point, I think. Exact and inexact interpolation. Okay, interpolators can be either exact or inexact. In the case of exact interpolations, at sampled locations, exact interpolators yield values identical to the measurement. The measured value and the predicted value will be exactly the same, That is exact interpolators. So if the observed temperature, like for example in one city, like for example in Gondar city is 30 degrees Celsius, the point representing Gondar city on the resulting grid will still have the temperature of 30 degrees. So the measured value of a variable will be the same as that of the predicted value of the variable. That is exact interpolators. But in the case of inexact interpolators, these inexact interpolators will predict the values that are different from the measured value. So the measured value will not be exactly the same as that of the predicted value, it means. Like if the observed temperature in CTA is like, for example, 90 degrees, the inexact interpolator will still create a prediction for CTA. And this prediction will not be exactly the same as 90, It may be 85 or maybe 70 or maybe 110 values, something like that, So the predicted value will not be exactly the same as that of the measured value. So the resulting surface will not pass through the original point. There will be just some mismatch, and can be used to avoid sharp peaks or throughs in the output surface, and model quality can be assessed by the statistics of the difference between the predicted and the measured values, So the better the interpolation technique will be just determined by assessing the statistics of the difference between the predicted and the measured value. So that will be the way how we can just choose the type of interpolation method. So this is generally, in short, about interpolation. Now hereafter we'll proceed just to use ArcGIS for demonstration of interpolation,